first. Thank you. Okay? The length, my guide is 1 centimeter over 2 meters. Correct?
Yes.
How am I going to figure out the 10 meters? Well, I'm going to put meters on top because I want my meters to cancel out. How many centimeters? 10 centimeters divided by 2, isn't it? Which is 5 centimeters.
How about my 10 on the bottom?
The 2, my 2 is on the bottom.
No, 10.
10. But why can't I have the 10 on the bottom? Because you shouldn't have gotten the right answer.
Because centimeters should be beside each other, and the meters are.
No. Look at what I'm trying to do. I have to, what we're doing is we're converting measurements using our guide. I want centimeters because what I'm trying to come up with is the scale drawing measurement. Oh, yes, you did. I got you. I got you. So you did it this way, which is still going to give me the same, again, more than one way to skin a cat. You had 1 centimeter over 2 meters is equal to 10 meters on the bottom, because your meters are on the bottom, x. 2x is equal to 10, divide both sides by 2, and you get 5 centimeters rock on. Okay, that's your length. Now let's find the width. For the width, we have 1 centimeter over 2 meters. Our width in our picture is 4.6 meters. Where does it go? Why does it have to go on the bottom? Because that's where my meters are, okay? Cross multiply, and I get 2x is equal to 4.6 divided by 2. Don't you get 2.3 centimeters? Yeah. How did you get one right and not the other right? Oh, did you not find the other dimension? Is that what you did? You found one dimension and didn't find the other? I heard folks say I didn't get one of them right. Maybe you were meaning number 8 or number 9. Okay, I got you. I'm with you now. Okay, but you got it now. All right, go back and rework it. Don't be satisfied with just letting me do it for you. You do it, because you got this. How about this? Cool with this now? All right, so let's look at number 10 real quickly. I think that was one of them you needed to see. It says find the perimeter. Well, look what we're given. Bless you. Perimeter of this is 14 centimeters. 4 centimeters. We got to find the perimeter of the big one. And all we're given is this right here, 6 centimeters. Okay? We got to find the perimeter. Look at what we're given. Is there enough information that in this problem where we can set up a proportion and solve? Okay, so how would I set it up? 4 over 6, because they correspond, is equal to 14 over x. You guys agree? 4x is equal to? Because it's given to you in the box. It's the perimeter of that rectangle was given. 24. Divide by 4, and you get x is 21 centimeters. Yes? Questions on that? Okay. Did you draw a picture? Why not? Don't be a lazy sack of poo. That's recorded. Don't be a slacker. Do your job, man. You know how to do this. And every single time when you draw a picture, you see it immediately. You literally see it and you understand immediately how to set this up. Okay? But you could have done it that way. It still would have given you the right answer. How? Because I could have said, if you know anything about rectangles, which you do, if this is 4, then that's 4, right? And the other two have to be equal to each other as well, yes? So it's 14, take away 4, which is 10. Take away 4, which is 6. Take 6 and divide it by 2, and you get 3. So that means this is 3 and this is 3. You with me? Okay. 4 over 6 is equal to 3 over what? 3 over what? 4x, 18, yuck. Somebody punch this up in a calculator for me. 4.5? See if that's 4.5. 18 divided by 4. Someone, please. Thank you. Okay? So 4.5. So that means that this side is 4.5. This side is 4.5. This is 6. 6 and 6 is 12. 12 and 9 is 21. More than one way to what? Skin that cat. This is common sense. Oh, okay. No, it wasn't a square. If it had been a square, then all sides would have been 4 or 6. Number 9, you should have had 4.3 by 2.
Yeah.
Okay. Maybe you rounded incorrectly, maybe. And then, what is the next one? The 4 causes the 3 to stay a 3. That's what it is. Yeah. Any other questions on this? All right, so let's finish. Guys, we are going to look at, here we go. I know, I cannot believe, but I'm not going to worry about that. Nothing? All right, so we're going to finish up this indirect, yep, this right here. We're going to recall what we learned on Monday. The scale for this diagram, for this doghouse, is 1 inch to 3 feet. Find the length of the actual doghouse. Let me move this so you can see. Tell me what we're going to do. 1 inch to 3 feet. Why does 0.75 go on top? Because it's in inches over x. Hey, cross multiply that up real quickly. Go get it. I have no idea. 2.25 what? Why is it feet? Because it's what we're looking for, smart Heine. That is correct. Now I want you to think about this. If it's 2.25 feet, have you ever seen a ruler or tape measure that literally measures 0.25 feet? It's actually 2 1/4 feet, isn't it? Which is, how much is 1/4 of a foot? How many inches? How was it 4?
24 inches and 140. No, it's 3.
Ah, it's 3. What's 1/4 of 12? 3. It should be 2 feet, 3 inches, because 1/4 of 12, write that over here. Remember, 1/4 of 12 1/4 of 12 is 3. It works out mathematically to be 3. So, which is the best answer? Depends on the options you're given. You may be given 2.25 feet. You may be given 2 1/4. You may be given 2 feet 3 inches. I don't know what you're going to be given on the SOL because, to be honest, when you guys are taking it, I'm not looking at it. I'm sitting in a corner doing my thing, okay? I walk around, but I don't pay any attention to what's on your screen. It could be one of those 3 answers, yes. No, absolutely not. It would not have all 3 of those. No way. Maybe. Maybe. We got to be prepared if we do. Here's one. And this kind of goes to what we were going over. Notice that your similarity ratio, which is just a side over a side, is the same as the perimeter ratio. These things are equal to each other. The similarity ratio and the perimeter ratio are equivalent to each other. They are equal to each other. The area ratio, if you'll look at it, if we were given that the area, look at what they did. The area of triangle ABC, which is 3 plus 5 plus 4, which is 8 and 4 is 12, right? That's the perimeter. The perimeter of triangle DEF is 10 plus 8 plus 6, which is 10 and 14, which is 24. Y'all cool with that? Oh, that's the perimeter. 12 over 24 is equal to 1/2, yes? Okay. But the area, you're told that the area of this triangle is 6 and the area of DEF is 24. At some point, you're going to have to find the area of those triangles, okay? 1/2 B times H. Right now is not the time we have to do that. But you do have to know that if we're given 6 over 24, you're going to reduce to get 1/4. And then you've got to think, what times itself gives you 1 over 4? 1 times 1, 2 times 2 is 1/4, right? Okay? So it's the similarity ratio squared. That's the area ratio, the similarity ratio squared. I just write something on the board. I might would put that in my notes. I'm just saying. Okay? Instead of just sitting there. But it says the proportional perimeters and areas theorem says that if the similarity ratio of two figures is A over B, then the ratio of their perimeters is the same, A over B. And the ratio of the areas is A squared over B squared. All right? One more time. Similarity ratio. If it's 2 over 3, then that means the ratio of the perimeters is the same, 2 over 3. This is just random numbers, okay? I'm not pulling these numbers from anything. These are just random numbers. Which means the ratio of the areas is going to be that thing squared. Which is 2 squared over 3 squared, which is 4 over 9. You guys see that? That's what that theorem says. The similarity ratio is equivalent to the perimeter ratio. And if you take that ratio and you square it, then you will have the ratio of the areas of the polygons, whatever they are. Triangle, square, rectangle, whatever. Okay? All right, so let's look at example 2. It says given, that probably shouldn't be a ratio, that should be triangle LMN is similar to triangle QRT. Given that they are similar, find the perimeter P and the area A of triangle QRS. Okay? Now, first thing I would do, this is totally based upon the theorem we just finished. First thing you want to do is you want to find the similarity ratio. Side over side. What? Pardon me? Hold up. All right, here we go. I mean, All right, so let's see, 13 divided by 9.1, because that looks kind of weird, having that, math bracket. Let's see what happens. Ah, ha, ha, ha. Smarty McFarty. What was it, 10 over 7? Okay. So our similar, because I don't want a decimal within a fraction. That's just weird. That's just, it totally is weird. They don't mix. They don't mix. I want a fraction, 10 over 7. Thank you, Daniel. Now, listen. I've got to find the perimeter of that triangle. Oh, hold up. Say it again. $13 over who? All right, so you're taking the side over the perimeter. If he goes this way, his other fraction has to be what, y'all? Look at it real carefully. 9.1 over who? We're dealing with perimeter. It's got to be x, because that's what we're solving for. All right, so let's see. 13x is equal to, I got to figure out what 36 times 9.1 is. Did y'all get 327.6? Okay. And we got to divide that by 327.6 divided by 13. No. No, I'm going Christmas lights up here. 25.2. How many of you got that? All right, look at way, this is the way Justin set it up. What?
I did it with the 13 over 9.1 is equal to 36 over x and the 10 over 7, and you still get 25.2.
You can do it either way. Here's what Justin did, okay? He took the information that we had, and we have a pair of corresponding sides available to us. We have 13 and we have 9.1. And he set those over each other, okay? Pardon me. He took the big triangle information and he set it equal to the little triangle information, didn't he?
Yeah.
Because 13 over 36 is all coming from the big triangle. Now, see, I'd have done it a little different, but it's fine to do it this way. So if he said 13, well, 13 has to correspond to 9.1, therefore I put 9.1 in the numerator of my second fraction. What am I trying to find? I'm trying to find the perimeter of that little triangle. Now, does this perimeter make sense? 25.2 for that little triangle.
No.
Why not?
Well, yeah, it does.
Why?
Because of
Well, because this one has decimals in it. Hey, and look at something else. This is a little, clearly, it's a smaller triangle, isn't it? Visibly, look at it. It's smaller. Not only that, the sides are smaller, therefore the perimeter has to be smaller. So does my answer make sense? Yes, my answer does make sense. And it's going to be 25.2 centimeters, which is the perimeter of triangle QRS. All right, that's the first part. Now we got to find the area. And this is where it can get a little bit tricky. Okay? I need for y'all to pay attention. That would be the best thing to do because it's bad if you're not. So let's look at it. Look back at that theorem. The theorem said that if their similarity ratio is A over B, then the ratio of their areas is A squared over B squared, correct? Right? All right, now let's see. go. The area, the area, the area, the area. We can't just use the similarity ratio now. We've got to use the ratio of the areas. So we've got to take 10 over 7, and we've got to square it. It would be the same as squaring 13 over 9.1. Hold up. Hold up. Wait a minute. Now, what number's going to go? What are we trying to find? We're trying to find the area of the smaller circle. So what triangle, not a circle. What number goes on top? Very good. Because, look, 10 comes from 13. 13 comes from the big triangle. Okay? That's going to help us find the area of the smaller triangle. These are weird problems, y'all. Because look inside the triangle. 60, okay? All right, here we go. 10 squared over 7 squared is 100 over 49. If you use 13 over 9.1, you're going to get the same answer. Pay attention. Be sure you pay attention. Pay attention. Here we go. Here we go. Let's go. Cross multiply. No, I don't have to square the right side. I only have to square the similarity ratio. Be 100x. What is 49 times 60, Dennis? Psst. Psst. Go ahead, Dennis. 2,940. And what do we do now? We divide by 100. I'm recording, and that was really loud. Someone's headphones? Okay. No, I don't think so. 29.4 once. Thank you, Brandon. 29.4 centimeters squared. Correct? Why do we have to square it? That's the louder I get, the louder my answers get. Because it's area. Very good. That is correct. Does everybody understand? Yes. Everybody's cold. Excuse me. Why does 60 go with 10? Because, here we go, watch it again. 10 comes from 13, right? Because I reduced, all we did was simplify. The 13 comes from the big triangle. The area of the big triangle is 60, right? Okay. Questions? Good. Here we go. Let's move on then. Ooh, look at this one. Ooh, what's missing? Picture. All right, here we go. ABC. And I may have this backward, folks, and if I do, I don't care. I just need a picture. It says that BC is 4 millimeters. EF is 12 millimeters. The perimeter for DEF. All right, perimeter is 42 millimeters. The area is 96 millimeters squared for triangle DEF. And we've got to find the perimeter and the area of ABC. This is the exact same thing that you just did, or we just did, in the last example. Here's what I want you to do. I want you to pair up with somebody in front of you, beside you, behind you, and do this problem all the way through. The first thing you got to do, look back now. You got to find the similarity ratio, find the perimeter of the triangle, and then find the area. Folks, we do the very same thing. Model what you did in the last example. Give it a shot. I'm going to give you 2 minutes. All right. Now, folks, here's the thing. When I looked at this, I'm going, so this is weird. Okay, this is strange. First thing I have to do is find the similarity ratio. That's a piece of cake. It does not matter how you go. The similarity ratio, I just go from left to right because I'm not told in my problem which way that I need to go. So I'm just going 4 over 12, and I reduce that to 1 over 3, right? That's my similarity ratio. That's the first thing I did. Second thing I did is I said, okay, let's look at the perimeter. Well, my perimeter, I know that my similarity ratio is equal to, and if you didn't know what to do, I would write this down. Your similarity ratio is equal to the ratio of your perimeters. Okay? That means that 1/3 is equal to, where did the 1 come from? Did it come from the little triangle or the big triangle? The 1 came from the little triangle. Do I know its perimeter? No, I don't know its perimeter. That's what I'm trying to find. So that's my P, or my X. The 3 came from the second triangle, and that perimeter is what? 42. How many of you had that much set up correctly? Whether you used 4 over 12, now watch what's going to happen, because you guys used 12 over 4, right? All right, watch what's going to happen. 3P is equal to 42. When you divide by 3, or what'd y'all divide by? 4? What do you end up getting? What's 42 divided by 3? 14. 14 what's? Millimeters. Because it's perimeter, and that's not what the... Excuse me, thank you. That's, when you're dealing with perimeter, it is the same as the similarity ratio. Okay? You just put your number in the wrong place. Oh, hold up. 4 over 42. You would have been 12. No. 4 would have been over your X because that's the perimeter you don't know. 12 would have been over 42 because look.
Oh, okay.
Perimeter is what I'm trying to find, and area is what I'm... So I could have said P over 42 is equal to 4 over 12. I could have done that one that way. That's the only thing you had to do. See, look, 4 over the perimeter, which we are finding, is equal to 12 over 42. That's what you need to change your paper to. You just had your numbers flipped, okay? How many of you had 14 millimeters? Hands up. That's good. That's very good. All right, so let's look at the area. Now, the area is the little, that's the weird one. Oh, come on. Yes, ma'am. Did you use 4 over 12? That is a similarity ratio that has not been simplified. It's still a similarity ratio that you didn't reduce. Because I could have used 3 over 1. You need to know that the similarity ratio is equivalent to the ratio of the perimeters. And the similarity ratio squared is equivalent to the ratio of the areas. That's all on that theorem. It's all based upon that theorem. Okay? Now, similarity ratio, because we're dealing with area, based upon that theorem says that the similarity ratio has to be squared, and that's going to be equal to the ratio of the areas. Okay? So, what's my similarity ratio? I used 1/3. And then look, the 1, look at it. The 1 comes from the 4. The 4 comes from the small triangle. Do I know the area of the small triangle? No. So that's going to be my A. Look at the 3. The 3 comes from the 12, and the 12 comes from the big triangle. What's the area of the big triangle? 96. Folks, if you didn't get this, I don't care if you don't care. You better write this down, okay? 1/3 squared, what is it? And you could have totally used 4/12 squared. If you had 12/4, then you should have had 96/A. But you didn't. But you had 12/4 and you didn't square it, right?
Yeah, we did.
For this area of the ratios, you had 144/16.
Yeah.
Did you have 96/A?
No,
That's what you did.
9/8.
There you go. There you go. Okay. Here we go. 9A is equal to 96. The area, what do you get? 10.6 repeating.
Okay, we got it.
Now, 0.6 repeating is what fraction? How much? I'm just asking just about 0.3 repeating. What fraction? No, not 0.3. 0.6 repeating is what? Not 1. Y'all are supposed to know this. It's 2/3, y'all. If you would have put 10.7 millimeters squared, I would have said that's fine. You ought to know that 0.6 repeating is 10 2/3 millimeters squared. Now, does that puzzle anybody? Look at those two numbers we found. Can the perimeter be more than the area? I would have thought not, but then I came over here because when I looked at this, listen, when I looked at this, I went, oh, that can't be right. But look, if you have a square that's 2, what's the perimeter of that square? 8. What's the area of that square? Okay, so can the area be smaller than the perimeter? Yes. I did this right here just to check that my numbers were G'ing and hawing, okay? Because that didn't make sense to me until I did this right here, and I went, okay, it's okay then. All right? Some of you are like deer in headlights. Just awesome.
I just learned how to do it.
Good. Then this is what you're going to do for homework. You're going to do examples 4 and 5 for homework. They are the exact same thing you just got finished doing. You find the similarity ratio, find the ratio of the perimeters, find the ratio of the areas for both of those problems.
So we work on partners.
No,